Tonight, we are going to talk about a world that at first glance does not look like a world at all. It looks like a frozen wound in the darkness. A white, cracked shell hanging beneath the shadow of the largest planet in our solar system. A moon so far from the warmth of Earth, so deep inside a violent radiation storm, that even machines would struggle to survive there for long. And yet, despite all of that, Europa has become one of the most important destinations in the future of space exploration. Because buried beneath that frozen crust, hidden under miles of ice, may be an ocean. Not a lake, not a pocket of water, an ocean. A global ocean. Dark, pressurized, ancient, and potentially alive. And that possibility changes everything. Because if Europa really does hide an ocean capable of supporting life, then this moon is no longer just another object orbiting Jupiter. It becomes a threshold, a dividing line in human history. The place where we may finally answer one of the oldest and most unsettling questions our species has ever asked. Are we alone? Or did life begin more than once in this universe? But there is a problem so severe that it changes the entire emotional meaning of a human mission to Europa. The first people who go there may not be the first people to conquer another world. They may be the first people to discover, in the hardest way possible, that some worlds do not forgive the attempt. Because Europa is not dangerous in the simple way that people imagine space to be dangerous. It is not only dangerous because it is cold. It is not only dangerous because it is far away. It is not only dangerous because it is alien. Europa is dangerous because it stacks catastrophe on top of catastrophe. Distance, radiation, surface instability, engineering failure, communication delays, isolation, extreme cold, unknown terrain, no rescue, no backup civilization nearby, no fast return, no margin for error that feels remotely human. Every system would have to work. Every stage of the mission would have to succeed. Every shelter, every seal, every cable, every power source, every layer of shielding, every life support loop, every decision made under pressure, all of it would have to hold. And if even one of those layers breaks at the wrong time, the consequences would not look like the kind of disaster most movies show you. It would not necessarily be one loud explosion and then silence. It could be slower than that, far more terrifying than that. A mission slipping from difficult to unstable, from unstable to unrecoverable, from unrecoverable to permanent. That is what makes Europa different. When people talk casually about humanity expanding across the solar system, they often say the same names. The Moon, Mars, maybe Titan, maybe the asteroids, sometimes Callisto, sometimes Ganymede, but Europa belongs in a category of its own. Because Europa is not simply a place where life would be hard. Europa is a place where survival itself may become a temporary condition, a place where the challenge is not landing. The challenge is not walking. The challenge is not even staying alive for a few days. The challenge is whether a human mission can remain reversible once it begins. And that is the real meaning of tonight's question. Why would the first humans on Europa never come back? Not because one single dramatic thing goes wrong. Not because the spacecraft necessarily crashes. Not because the crew is careless. But because Europa may represent a form of exploration where the deeper humanity goes, the less return remains part of the mission in any practical sense. A place where every kilometer traveled, every system deployed, every hour spent on the surface, pushes the crew further into a chain of dependency that cannot easily be undone. If they go down through the ice, they are isolated. If the ascent systems fail, they are trapped. If radiation damages the wrong components, the return architecture collapses. If life support becomes unstable, there is no emergency room, no nearby station, no rescue ship on standby. Nothing comes quickly in deep space. And on Europa, time itself becomes part of the threat. That is why this moon fascinates scientists and terrifies mission planners in equal measure. Because Europa may be one of the most scientifically valuable places in the entire solar system. It may be a world where chemistry, water, energy, and time have interacted in the dark for billions of years. It may contain the closest thing we have ever found to an alien ocean. But the very features that make Europa scientifically irresistible also make it brutally inhospitable to human survival. The ocean we want to reach is buried beneath a shell of ice, thick enough to defeat ordinary exploration. The surface we want to stand on lies inside a radiation environment that can shred unprotected biology and degrade hardware. The moon we want to understand is so far from Earth that any serious emergency becomes a slow-moving crisis with no external lifeline. So this is not just a story about space exploration. It is a story about limits, about ambition, about what happens when curiosity takes us to a world where the conditions are not merely hostile, but fundamentally indifferent to the fragile systems that keep human beings alive. And by the end of this journey, I want you to see Europa differently, not just as a beautiful icy moon, not just as a potential ocean world, not just as a place where alien life might exist, but as a test, perhaps one of the greatest tests humanity will ever face in space. A test of engineering, a test of endurance, a test of judgment, and maybe, more than anything else, a test of whether every destination worth reaching is actually a destination meant for us. Before we go deeper, if you love these kinds of long-form space documentaries, where we take one idea and follow it all the way down to the edge of what it really means, subscribe to Skyline Trek and join us on the journey. And if this kind of exploration matters to you, leave a like on the video. It helps this channel reach more people who still look up at the night sky and feel that pull toward the unknown. Now let's begin where every Europa story must begin, with the moon itself. Because before we can understand why the first humans might never come back, we have to understand what Europa really is. Not the simplified version, not the romantic version, the real one. And the real Europa is far stranger than most people realize. 2. Europa, the frozen moon beneath Jupiter's shadow. Europa is one of Jupiter's 4 great Galilean moons. Discovered by Galileo in 1610 when he turned a telescope toward Jupiter and noticed small points of light shifting position night after night. Those lights were not stars, they were moons, and among them was Europa, a world that for centuries was little more than a distant speck, a bright point of light moving around a giant planet. But over time, as telescopes improved and robotic missions crossed the solar system, that point of light transformed into something else entirely. Not a speck, a real world, a frozen world, a deeply mysterious world. Europa is slightly smaller than Earth's moon, but in terms of scientific significance, it may be one of the largest destinations in the future of planetary exploration. Its surface is made primarily of water ice, and unlike many rocky worlds that are scarred by mountains, craters, and obvious violent histories, Europa presents a face that is strangely smooth in places, fractured in others, and covered in long dark streaks and lines that make it look less like a normal moon and more like a cracked eye staring back across the solar system. It is one of the most visually distinctive objects we have ever observed, and that appearance is not cosmetic. It is a clue. Those cracks, ridges, bands, and disrupted regions suggest that Europa is geologically active in some way. Not active like Earth, with forests, weather, and plate tectonics, but active enough that its surface is being renewed, shifted, broken, and possibly reshaped over time. That matters, because worlds that change are often worlds with energy, and where there is long-term energy, scientists start asking a very important question: what else might be happening beneath the surface? That question became far more serious once evidence began to point toward the existence of a global ocean below Europa's ice shell. A vast body of liquid water hidden under the frozen crust, kept from freezing solid, not by sunlight, because Jupiter is far too distant from the sun for that, but by tidal heating. Jupiter's gravity is immense. Europa is pulled, stretched, and squeezed as it orbits the gas giant, and those repeated gravitational distortions create internal friction. That friction generates heat. Over long periods of time, that heat may be enough to maintain liquid water beneath the ice. Now pause for a moment and think about how extraordinary that is. An ocean world. Not on Earth, not under a blue sky, but beneath a lid of ice on a moon orbiting Jupiter. An ocean in darkness, an ocean under pressure, an ocean that may have existed for billions of years, and suddenly Europa stops being just another moon. It becomes one of the most compelling environments in the search for extraterrestrial life. But if we are going to understand why Europa may trap the first humans who reach it, we need to keep two truths in our minds at the same time. The first truth is that Europa is scientifically beautiful. It may be one of the most important natural laboratories in the solar system, a world where water, energy, chemistry, and time may have combined in ways that produce biology. Maybe not intelligent life, maybe not anything complex, but perhaps microbial life, hidden in a dark ocean, using chemical energy, in ways that feel eerily familiar to some of the environments we find near deep-sea hydrothermal systems on Earth. The second truth is that Europa is physically merciless, because this is not an ocean world in any comfortable sense. The ocean is buried, the surface is lethal, the environment around the moon is dominated by Jupiter, and Jupiter is not a passive giant in the background. Jupiter controls the entire emotional reality of Europa. Its gravity helps warm the interior, yes, but its magnetosphere also floods the region with radiation. Europa is effectively living inside the machinery of a planetary giant. That means the moon is both promising and punishing at the same time. The very system that may help keep the ocean liquid is also part of what makes the surface so unforgiving. And even before we get into the radiation in detail, Europa's surface by itself should already unsettle us. This is not a world with breathable air. In fact, Europa's atmosphere is so thin that for practical human purposes, it may as well not exist. There is no weather in the way we understand weather on Earth. No sky you could stand under and survive. No natural pressure that supports your body. No surface warmth. No open water. No exposed ecosystems. Just a frozen crust stretched over a hidden abyss. A crust marked by fractures that may record internal movement, exchange, and stress. Some regions look as though parts of the surface have broken, rotated, and refrozen. These terrains do not suggest calm stability. They suggest history, tension, and change. That has enormous implications for any future mission. Because when people imagine walking on another world, they often imagine the surface as a stage. Something solid, something passive, something you land on and then begin exploring. But Europa's surface may not be passive at all. It may be brittle in some places, jagged in others, deeply structured, unpredictable, and far less well understood than the public tends to assume. A landing system would not simply need to arrive. It would need to arrive on a surface whose properties are still only partially known. And if human exploration ever advances beyond orbit and flybys towards surface operations, then the first crew would not be stepping onto certainty. They would be stepping onto a frozen puzzle. Europa also lives in perpetual emotional contrast. From a distance, it is serene, white, bright, almost elegant. But everything that makes it serene at visual scale becomes threatening at human scale. The smoothness can hide danger, the brightness hides radiation, the ice hides depth. The beauty hides the fact that this is a world profoundly incompatible with unprotected human life. That is the key to understanding Europa. It is not a dead rock where nothing matters. It is not a warm ocean paradise waiting to be reached. It is a layered world, a concealed world, a world that gives away very little for free. And that is exactly why scientists are obsessed with it. Because if Europa were easy to understand, it would not matter nearly as much. Its mystery is part of its power. The hidden ocean is part of its power. The possibility of chemistry beneath the ice is part of its power. The uncertainty is part of its power. Europa keeps inviting us closer, while simultaneously warning us that closer is where the real danger begins. If that sounds dramatic, it should. Because in many ways, Europa is the perfect example of what the future of exploration may look like. Not the easy destinations, not the obvious ones, but the ones where the greatest scientific payoff is wrapped inside the greatest operational risk. The places where every answer must be earned through extreme difficulty. And for a human mission, that difficulty would not begin after landing. It would begin much earlier, long before boots ever touched Europa's ice. The crew would already be on a mission unlike anything humanity has attempted before. A mission measured not just in distance, but in commitment. A mission moving farther and farther from rescue, from redundancy, and from Earth's protective reach. Because the first terrifying thing about Europa is not the moon itself. It is what it takes to get there. Before we go on, if you're enjoying this deep dive, subscribe to Skyline Trek. This channel is for people who do not just want headlines about space. They want the full story, the scale, the danger, the science, and the meaning behind it. So if that sounds like you, become part of Skyline Trek. Now let's talk about why scientists want to go to Europa in the first place. Because unless you understand the magnitude of what might be hiding there, you cannot understand why humanity would ever accept the risks required to reach it. 3. Why scientists are so desperate to reach it. If Europa were only cold, distant and difficult, it would still be an impressive moon, but it would not inspire the level of urgency and fascination that it does today. The reason Europa matters so much is not simply because it is a strange place. It matters because Europa may be one of the few worlds in the solar system where the ingredients for life have existed together for a very long time. And once that possibility enters the conversation, the moon stops being just another object of study. It becomes a destination that could redefine humanity's understanding of biology, evolution, and our place in the cosmos. Let's be clear about the scale of that possibility. If life exists, or once existed on Europa, then life did not happen only once. It did not belong exclusively to Earth. It did not require a planet with forests, oceans under open skies, and a warm blue atmosphere. It emerged, or at least persisted, in darkness beneath ice, on a moon orbiting a giant planet far from the sun. And that would mean biology is not a singular accident, limited to one fragile world. It would mean the universe may be far more fertile, far more chemically creative, and far less lonely than humanity has long suspected. That is not a small scientific prize. That is one of the biggest discoveries our species could ever make, and that is why Europa has become an obsession. Scientists are not drawn to Europa because it is easy. They are drawn to it because it may be worth the difficulty, worth the decades of planning, worth the engineering, worth the cost, worth the risk. Because beneath the ice may lie an environment where liquid water, internal heat, and potentially useful chemistry have coexisted for billions of years. On Earth, wherever we find long-term liquid water and available energy, life tends to show up in astonishingly resilient forms, in boiling vents, in frozen deserts, deep underground, beneath the seafloor, in extreme acidity, under enormous pressure. Life on Earth has repeatedly demonstrated that biology is opportunistic. Give it time, energy, chemistry, and a stable environment, and it may find a way. Europa appears to offer at least some version of those ingredients. Water, almost certainly in huge volume beneath the ice. Energy, likely supplied through tidal heating and possibly other internal processes. Chemistry, potentially driven by interactions between the ocean, the rocky mantle below, and materials cycled from the irradiated surface. That last part is especially important. One of the reasons scientists get excited about Europa is that it may not be a completely sealed, static ocean. There may be exchange between the surface and the subsurface. Surface radiation can produce oxidants and other chemically interesting compounds in the ice. If some of those materials are transported downward into the ocean, and if materials from the interior or seafloor come upward, then Europa may host chemical gradients capable of supporting metabolism. On Earth, chemical gradients are life's playground. They create opportunities for energy transfer, and energy transfer is at the heart of biological activity. In other words, Europa may not simply have water. It may have a system where the ice shell, the ocean beneath it, the internal heat source, and the surface chemistry all interact over immense timescales. And if that is true, then Europa is not just a frozen moon. It is a living question, a hidden environment where biology may have had time to begin, adapt and persist in complete darkness. Now imagine what it would mean to confirm that. Imagine lowering instruments through ice into a black extraterrestrial sea and finding evidence of organic chemistry so complex it cannot easily be explained without life, or finding patterns in the water that suggest metabolism, or discovering cells, or biofilms, or even just isotopic signatures that point to active biological processes. Even microbial life would change history. It would transform philosophy, religion, biology, and planetary science in one stroke. The universe would immediately feel more inhabited, more dynamic, and more biologically possible than it does now. That possibility exerts a kind of gravity on science itself. It pulls missions toward Europa. Because if there is even a chance that another ocean in our own solar system hosts life, then walking away from that question becomes almost impossible. Humanity can postpone it. Redirect funding, focus on Mars or the Moon or telescopes or other priorities. But the question remains, and as long as it remains, Europa will continue calling scientists back. But the desperation to reach Europa is not just about finding life directly. Even if Europa turns out to be sterile, it is still one of the most valuable worlds we could study, because understanding why it is sterile would teach us almost as much about habitability as discovering life would. If Europa has all the apparent ingredients, but no biology, then something crucial is missing. Some threshold was not crossed. Some mechanism did not work. Some condition we assumed was sufficient may not be sufficient after all. That too would reshape science. So either way, Europa matters. If there is life, we discover that biology can emerge more than once. If there is no life, we learn something profound about the limits of habitability. And because of that, Europa stands at the center of one of the most important scientific quests in modern history. But here is where the emotional structure of this story becomes more complicated. The more valuable Europa becomes scientifically, the more willing humanity may become to accept extraordinary risk in order to reach it. That is a dangerous equation, because scientific importance has a way of bending mission psychology. It creates pressure, it creates urgency, it creates the temptation to justify risks that might otherwise feel unacceptable. A world that promises one of the greatest discoveries in history becomes a world where engineers, planners, governments, and perhaps eventually astronauts themselves may be willing to push farther than they should. That is how frontier disasters begin. Not with stupidity, not with carelessness, but with importance, with the belief that the destination is too significant to ignore. And Europa may be exactly that kind of destination. A place so meaningful that humanity keeps inching toward it, even while every layer of the mission grows more complicated. First flybys, then orbital studies, then detailed mapping, then perhaps a lander, then perhaps robotic penetrators or cryobots to melt through the ice, then perhaps autonomous submersibles. And if all of that continues to reinforce the moon's promise, if every new dataset says the same thing, that Europa may indeed be one of the most habitable places beyond Earth, then the conversation changes. It no longer becomes should we explore Europa? It becomes how could we not? That is when the human mission begins to feel inevitable. And that is when the danger becomes more philosophical. Because once a destination feels inevitable, people begin to assume it is ultimately survivable. They begin to treat possible and wise as if they are the same word. They are not. Europa may be technically reachable long before it is responsibly survivable. In fact, those two thresholds may be separated by decades, or they may never fully overlap at all. That is the tragedy hiding inside the dream of Europa. The place may be worth going to, but not with us, or not yet, or not in the way our imagination prefers. And still the urge remains, because this is how humanity works. We are not content with distant speculation forever. Once we know a hidden ocean may exist, we want to sample it. Once we suspect chemistry, we want to measure it. Once we think life may be there, we want proof. And once robotic missions reveal enough, there will come a moment when the question shifts from machinery to presence, from probes to people, from observation to arrival. When that day comes, the crews selected for such a mission would know exactly what Europa represents. They would understand that they are not going for spectacle, not for tourism, not for a symbolic footprint. They would be going because history is asking something of them, because the search for life has led to a frozen moon beneath Jupiter, and humanity has decided that this question is worth carrying a human body across the deep dark to answer. And that is exactly why the danger is so serious. Because human beings do their boldest things not when the stakes are low, but when the meaning is highest. Europa gives the mission meaning. Enough meaning to make it irresistible. Enough meaning to make it emotionally heroic. Enough meaning to make people forget that significance does not make a place survivable. Before we move on, if you're still with me, subscribe to Skyline Trek. This channel is built for viewers who want more than surface-level space content. We slow down, go deeper, and really ask what these missions would mean. So if that kind of journey speaks to you, Skyline Trek is where you belong. Now that we understand why scientists are so desperate to reach Europa, we need to confront the next layer of the problem. Because even before the radiation, even before the ice, even before the surface itself, a human mission to Europa is already in trouble for one simple reason. Getting there pushes you beyond rescue. 4. The journey there is already beyond rescue. There is a dangerous illusion that often sneaks into conversations about deep space exploration. It is the illusion that distance is just a number, a matter of engineering, a matter of fuel, time, trajectory, and patience. A problem for propulsion systems and mission planners, but not something that fundamentally changes the emotional and physical reality of a crew. That illusion works for a while when we talk about Earth orbit. It even survives, to some extent, when we talk about the Moon. But by the time you start talking seriously about sending humans to Europa, that illusion has to die. Because distance is not just distance anymore. Distance becomes vulnerability. A mission to Europa would not simply be a longer voyage. It would be a mission operating in a realm where almost every concept humans rely on for safety begins to fall apart. Rescue, redundancy, immediate support, rapid response, spare infrastructure, nearby shelter, emergency return, all of these ideas weaken as the spacecraft moves outward through the solar system. And by the time a crew reaches the Jovian system, those ideas may no longer describe reality in any meaningful sense. To understand that, we need to stop thinking like tourists of the imagination and start thinking like the people who would actually have to build such a mission. A human journey to Europa would be vast, complex, and unforgiving. It would likely involve years of planning for every phase, and the transit alone could take an enormous amount of time depending on propulsion systems, launch windows, gravity assists, mission architecture, and payload mass. This would not be a short hop. This would be a prolonged expedition through deep space, with human beings enclosed inside machinery that must continue performing correctly for far longer than any ordinary survival environment on Earth is ever asked to. That matters because every long-duration space mission accumulates risk. Not just one risk, layers of risk. Hardware ages, materials fatigue, seals weaken, components drift out of tolerance. Radiation accumulates damage in electronics. Humans lose muscle, bone density, and psychological stability under confinement. Closed-loop life support systems become ecosystems of maintenance and failure points. Supplies diminish. Unexpected problems compound. And on a mission to Europa, every one of those risks would be amplified by the fact that Earth is no longer close enough to matter in any immediate operational sense. That is the core truth people often underestimate. If something goes wrong on the International Space Station, the situation is serious, but not hopeless by default. There are procedures, communication in real time, existing infrastructure, and at least some concept of rapid support. Even on a lunar mission, while rescue would still be extremely hard, the Moon is close enough that emergency planning remains within a recognizable human timescale. But Europa exists in another category entirely. The Jovian system is not nearby. It is not accessible in the emotional sense human beings evolved to understand. It is not a place where a second launch can quickly change the fate of a crew. If disaster begins there, the crew lives inside the disaster. They do not wait for fast intervention, because there is no fast intervention. They do not expect a rescue ship in days, because that is fantasy. They do not assume mission control can solve everything through calm instructions, because some failures cannot be instructed away. At that distance, the crew is not simply exploring far from home, and the journey itself would remind them of that every day. Think about what long-duration confinement in space already does to people. Isolation changes perception. Repetition changes mood. Small tensions grow larger. Habitats become psychologically dense. Privacy shrinks. The mind starts carrying the weight of distance in ways that are difficult to simulate on Earth. Now extend that not merely to a Mars mission, but to an even deeper and more isolated voyage, aimed at one of the harshest environments in the solar system. The crew would know that every day of transit is not just progress toward discovery. It is also progress away from reversibility. That is one of the most haunting parts of a Europa mission. There would come a point where turning around is no longer practical. A point where the return plan, even if technically retained on paper, becomes subordinate to arrival logistics, fuel commitments, orbital mechanics, and mission priorities. At that point, the mission does not merely continue, it commits. And commitment in deep space is a frightening word, because it means the crew is no longer moving through a scenario where safety remains flexible. They are moving through a chain of irreversible decisions. Every day closer to Jupiter is a day farther from rescue. And then there is the issue of communications. Even before a crew reaches Europa, they would already be operating with delays that erode the comforting illusion of instant support from Earth. We are used to a world where communication is immediate, where help can be coordinated in real time, where a voice can answer a crisis as it unfolds. Deep space strips that away. There is delay, there is lag, there is the psychological burden of saying something critical and then waiting, acting and then waiting, hoping and then waiting. That changes how emergencies feel. It changes leadership. It changes medicine. It changes fear. A crew on the way to Europa would need to be radically autonomous, because in practical terms, they would be alone long before they ever arrived. Autonomy sounds noble in planning documents. In reality, it means the crew must carry not only the mission, but the burden of final responsibility. If a life support issue emerges, they solve it. If medical trouble appears, they handle it. If some subsystem starts behaving unpredictably, they diagnose it. If morale begins to fracture, they absorb it. Earth can advise. Earth can support emotionally. Earth can calculate. But Earth cannot reach across the void fast enough to restore broken hardware, or replace consumed supplies, or physically stabilize a spiraling situation. This is what makes the phrase "beyond rescue" so important. It does not mean people stop caring. It does not mean mission control gives up. It means the architecture of reality changes. Care without reach is not rescue. Advice without proximity is not rescue. Hope without intervention is not rescue. And if all of that is true during the journey, before Europa is even beneath the spacecraft, then imagine what happens once the crew enters Jupiter's system. Because the transit is only the first threshold. After that comes orbital insertion, radiation exposure, operational constraints, and surface mission deployment. Every new phase adds more complexity to an already overextended structure. The ship that delivered the crew is no longer just transportation. It becomes home, hospital, workshop, command center, psychological shelter, and eventually perhaps the only link between the people on the surface and any possibility of departure. That means the voyage to Europa does not merely deliver explorers to a moon, it transforms the mission into a closed world. A world where every failure remains inside the same machine. A world where no outside civilization can arrive on time to change the outcome. A world where the ordinary safety net of humanity has stretched so thin that it may as well not exist. Once you understand that, everything else about Europa becomes more frightening. Because now the surface dangers are not happening in isolation. They are happening on top of a mission architecture already pushed to its limits by distance, delay, and permanence. The moon is not the only threat. The journey has already turned the crew into a self-contained system at the edge of what human support can meaningfully sustain. And that means when we eventually discuss radiation, cold, surface instability, habitat fragility, and the problem of coming home, we are not describing independent obstacles. We are describing threats acting on a mission that is already too far away to fail safely. Before we continue, subscribe to Skyline Trek if you want more space documentaries that go beyond the surface and really unpack what these future missions would mean for actual human beings. This is exactly the kind of frontier where science, engineering, and existential risk collide. And now we need to confront the most brutal layer of Europa's reality. Because as hard as the journey is, the real violence begins when you get close. Europa orbits inside one of the deadliest radiation environments in the solar system, and that changes everything. 5. Jupiter's radiation makes Europa nearly unlivable. If Europa were only far away, humanity would still dream of reaching it. If Europa were only cold, we would design heaters, habitats, and power systems. If Europa were only buried beneath ice, we would develop drills, melt probes, and robotic penetrators. But Europa is not only any one of those things, it is all of them, and wrapped around all of them is the most immediate surface-level reason a human mission becomes terrifying: radiation. This is the point in the story where Europa stops sounding merely difficult and starts sounding fundamentally hostile. Because Europa orbits deep inside Jupiter's magnetosphere, and Jupiter's magnetosphere is not some abstract scientific term that can be politely ignored. It is enormous, violent, dynamic, a charged particle environment of staggering intensity. Jupiter's magnetic field traps energetic particles and floods its surrounding space with radiation levels that make many other places in the solar system look almost gentle by comparison. Europa sits inside that environment. It is not near it. It is not occasionally affected by it. It lives inside it. And that means the Moon's surface is continuously exposed to an invisible storm. This matters in two ways at once. First, it matters for machines. Second, it matters far more for people. Let's begin with the machines, because even that part is serious enough to reshape an entire mission architecture. Electronics do not like radiation. Sensors can degrade. Memory can corrupt. Components can fail. Repeated exposure can slowly eat away at the reliability of systems you are depending on to stay alive. Shielding helps, but shielding is heavy, and heavy things are expensive to launch, difficult to maneuver, and brutal on mission design. Every kilogram matters in deep space. So the problem is never solved by simply adding more and more protection forever. The mission becomes a balancing act between survivability and feasibility. And if electronics are under stress, everything is under stress. Navigation, power regulation, communication systems, scientific instruments, habitat control, robotic assistance, drilling systems, vehicle systems, ascent systems, suit support, surface transport. All of it depends on hardware. All of it depends on electronics functioning correctly under a radiation load that is far beyond ordinary operational environments. This means Europa is not just a place where danger waits for human skin. It is a place where the environment actively works to degrade the very systems humans would rely on to remain alive. Now consider the human body. Human beings are not built for radiation. We are not a species that evolved under particle bombardment in vacuum. We evolved beneath a thick atmosphere and a magnetic shield that protects us from much of the violence of space. Even low Earth orbit already teaches us that radiation exposure is a serious concern for astronauts. Move out into deep space and the problem grows. Move into the Jovian system and the problem becomes extreme. On Europa's surface, unprotected exposure would not be some distant health concern to worry about in retirement. It could become an acute operational emergency, a countdown, a mission-defining limit. This is one of the most sobering truths about Europa. A person cannot simply step outside and work for long, as if this were just another moon landing under a different sky. Every excursion would be shaped by radiation budgets. Every habitat would need shielding. Every route, every procedure, every emergency plan, every surface timeline would need to assume that outside the protected zones, the environment itself is injuring you. Not metaphorically, physically, invisibly, continuously. That changes the psychology of exploration in a profound way. Because on many worlds, the danger feels environmental but readable. On Mars, dust storms are visible. Terrain is visible. The cold is measurable. The thin atmosphere is obvious. On Europa, one of the deadliest threats cannot be seen at all. It does not roar. It does not crack under your boots. It does not cast a shadow. It is simply there, passing through matter, penetrating tissue, degrading systems, accumulating harm with every moment spent exposed. That invisible quality makes radiation uniquely terrifying. It also means the crew's relationship with the surface would be fundamentally different from the romantic image people often carry in their heads when they imagine human exploration. Europa would not be a place to wander. It would be a place to endure in controlled bursts. A place where outside time is rationed. A place where every activity has to be optimized, because the environment is charging interest on your existence every second you remain exposed. And even if a crew had heavily shielded habitats, shielded rovers, shielded ascent vehicles, and highly protective suits, the radiation problem would still not disappear. It would shape everything. Habitat placement, surface duration, power allocation, maintenance demands, safe zones, buried structures, ice shielding strategies. The mission might even rely on using the moon's own ice as part of its protection, placing habitats under ice berms, or within excavated trenches, or specially designed sheltered zones to reduce exposure. But every layer of protection introduces engineering complexity. More systems to deploy, more mass to carry, more points of failure. That is the larger pattern we keep seeing with Europa. Every solution arrives attached to another problem. Need shielding, add mass, increase mission difficulty, increase complexity, increase failure points, increase failure points, increase the odds that one thing breaks in the wrong place at the wrong time. And on Europa, the wrong place could be anywhere. There is also a strategic consequence to the radiation environment that people do not talk about enough. It compresses the mission. It reduces freedom. It reduces flexibility. It means that delays that might be survivable elsewhere become far more dangerous here. If a rover stalls, if a hatch jams, if communications glitch during an EVA, if a power transfer takes longer than planned, if the crew is forced to remain exposed outside protected zones for longer than expected, radiation is not waiting politely in the background. It is actively worsening the situation. That is what makes Europa almost uniquely unforgiving. It turns time itself into a threat multiplier. Minutes matter more, delays matter more, improvisation becomes harder, errors become more expensive. Now imagine the first human crew knowing all of this before they even land. Imagine descending toward a moon where the surface is not just unknown, but actively toxic in a way your senses cannot detect. Imagine suiting up for the first EVA, knowing that you are stepping into a place where the environment is attacking both your body and your machinery simultaneously. Imagine living in a habitat where your shelter is not merely comfort, but your only meaningful defense against an invisible storm. That would change the mental landscape of every mission decision. And it also explains why some mission architectures may eventually conclude that if humans ever operate on Europa, much of their infrastructure would need to be buried, shielded, or kept beneath heavy protection from the start. In other words, the crew might not truly be living on Europa in any open sense at all. They would be hiding from Europa while attempting to study it. That distinction is important, because when people say humanity will one day go to Europa, the phrase makes it sound like we will arrive and inhabit the place in some recognizable exploration mode. But the reality may be the opposite. Europa may only be survivable if humans minimize their contact with the actual surface environment as much as possible. That means protected habitats, fast operations, intense radiation accounting, and perhaps even mission rules so strict that every movement outside becomes a carefully controlled act of measured risk. And if that is true, then the first crew would not experience Europa as a frontier in the romantic sense. They would experience it as siege. A siege against radiation, a siege against time, a siege against engineering failure, a siege where the moon itself never stops pressing against the limits of human protection. This is why radiation is not just another technical issue on the mission checklist. It is one of the central reasons the title of this documentary may ultimately be true. Because if radiation damages the wrong systems, the return mission may fail. If radiation limits surface operations too severely, key tasks may not be completed. If shielding proves insufficient in practice, crew health may degrade. If exposure during an emergency exceeds safe thresholds, the mission may become unrecoverable not in one moment, but in a sequence of escalating compromises. And here is the cruelest part. Radiation does not need to kill quickly to end the mission. It only needs to force enough weakness into the system that other failures become impossible to manage. That is how Europa traps people. Not with one dramatic monster in the dark, but with layers of physical reality, invisible, cumulative, relentless. Before we move to the surface itself, subscribe to Skyline Trek if you want more deep space documentaries like this. This channel is for people who want the real scale of these missions, not simplified headlines. So if that sounds like your kind of journey, join Skyline Trek. And now we come to a dangerous misconception about human exploration. Many people think landing is the hard part. On Europa, landing may be the moment the real danger finally begins. Why landing would only begin the real danger? There is something deeply powerful about the image of landing on another world. It compresses everything into one cinematic moment. The descent, the engine burn, the dust or ice beneath the vehicle. The first confirmation that the landing gear held. The crew breathing out. The words exchanged inside the cabin. The sense that humanity has arrived. We are trained by decades of storytelling to treat that moment as victory, as the climax, as the point where the mission crosses from uncertainty into success. But Europa does not fit that emotional pattern. On Europa, touchdown would not be the end of the hardest phase. It would be the opening of a much longer and more dangerous one. Because the act of landing on the moon does not solve the mission's most serious problems. It only places the crew inside them. That is the essential truth. A spacecraft descending to Europa would be approaching a surface that remains, in many ways, only partially understood. Yes, we can map. Yes, we can study from orbit. Yes, robotic precursor missions can reveal more. But there is a profound difference between observing a frozen terrain and trusting it with human lives. The surface of Europa is not a featureless slab of ice. It is a fractured, patterned, geologically suggestive shell, marked by ridges, bands, disrupted terrain, and regions that appear to have undergone stress, breakage, and rearrangement. Some areas look cracked, some look shifted, some look like they were broken apart and frozen back into place. None of that inspires the kind of calm confidence you would want before sending human beings to stand on it. Because a surface like that raises uncomfortable questions. How stable is it locally? How brittle is it? How much variation exists in texture, load-bearing capacity, roughness, or subsurface void structure? How predictable is the interaction between landing systems and ice that may behave very differently from what simple intuition suggests? On Earth, ice can crack, shift, conceal weakness, and betray weight in ways people who live around it learn to respect. Now imagine scaling that uncertainty to an alien moon under cryogenic conditions, with a surface history shaped by tidal stress and radiation processing, and trying to place a human-rated landing system onto it, with no possibility of trial and error in the ordinary sense. A robotic probe can fail and still teach us something. A human landing system does not get the same kind of freedom. The first landing site would have to be chosen with extraordinary caution, and even then caution does not create certainty. It only manages ignorance. That is what makes Europa's surface so unnerving. It is not merely dangerous because it is cold and empty. It is dangerous because it may contain forms of instability that remain hidden until interaction begins. A spot that looks acceptable from above may prove jagged, sloped, mechanically inconsistent, or hazardous in ways that only close contact reveals. The landing system itself would need to account for this, perhaps through advanced hazard detection, autonomous correction, site rejection logic, and landing gear designed for uncertain icy terrain. But all of those systems increase complexity, and as we have seen again and again in this story, complexity on Europa is never free. It always arrives carrying more mass, more power demand, more software burden, and more opportunities for failure. Now suppose the landing succeeds. Suppose the vehicle touches down beautifully. The structure holds. The site is workable. The crew survives descent. From the outside, history has been made. In reality, the most terrifying phase may just be starting, because from that moment on, every system transitions from transport mode to survival mode. The lander is no longer just the machine that brought the crew here. It may be one of the most important pieces of life support architecture the mission has. It may provide shielding, communication support, ascent capability, power routing, shelter, navigation coordination, and redundancy with the habitat. That means the landing system cannot simply succeed once. It must remain healthy. It must keep working in a radiation environment, on an icy surface, under thermal stress, while supporting operations that may continue far longer than the descent itself lasted. And around it, the surface waits. This is where the story shifts from can we land to can we stay alive after we do. Because stepping onto Europa would not mean entering a stable exploration zone. It would mean beginning operations on a moon where the environment is trying to exploit every weakness in the mission design. The cold pushes materials toward brittleness. Radiation attacks electronics. Vacuum isolates systems thermally. The terrain may resist mobility. The hidden structure beneath the local ice may be unknown. Fine details of footing, traction, drilling resistance, mechanical anchoring, and structural load transfer might all behave in ways that force constant adaptation. This is not like standing on rock under a thin sky. This is standing on the frozen skin of a world that may be active, fractured, and profoundly alien in its mechanical behavior. Even simple movement could become psychologically different there. Walking on Europa would not carry the triumphant freedom of a first stroll on a forgiving surface. Every step would be embedded inside mission constraints. Suit integrity, radiation time, thermal management, surface condition, route confidence, communication links, return path certainty. On Earth, if you trip during a field expedition, it is embarrassing. On Europa, a fall, a damaged seal, a misjudged traverse, or a delay in returning to shelter could initiate a chain of consequences that escalates fast, not because the moon is dramatic, because it is indifferent. And that indifference is what makes the first landing so deceptive. Touchdown creates the emotional illusion that humanity has gained control, but in truth, the crew may have only succeeded in placing themselves inside an environment they still do not command. That is why landing would only begin the real danger. The mission after landing becomes a long negotiation with failure, not because failure is guaranteed, but because the crew must assume it is. That makes habitat fragility one of the most important and least emotionally understood aspects of the mission. People often imagine future off-world habitats as strong, stable, even slightly heroic structures, domes on Mars, bases on the Moon, stations in orbit. But Europa would likely force a much more humble kind of habitat design, not something proudly standing in open defiance of the environment, but something intensely protected, heavily engineered, and perhaps even hidden as much as possible. A habitat that survives not by dominating the Moon, but by minimizing how much of the Moon can reach it. That is an important mental shift, because on Europa, the habitat would not represent conquest, it would represent retreat, a pocket of human warmth inside a place that wants to freeze machinery, harden polymers, stiffen joints, stress materials, and make every repair harder than it should be. Now think about what that means psychologically for the first crew. Every time they return from an EVA, the habitat is not just where they sleep, it is where survival resumes. Every sealed door is meaningful. Every functioning heat exchanger matters. Every stable internal temperature reading becomes emotional reassurance. And any sign that the habitat is underperforming, even slightly, would hit the crew with a kind of fear that is difficult to overstate. Because unlike on Earth, where environmental failure often exists within reach of external help, on Europa, the habitat is the help. If the habitat weakens, the crew weakens with it. And habitat fragility is not only, it collaborates with every other threat we have discussed. That is the pattern that keeps making Europa so terrifying. No danger stays isolated. Radiation makes equipment less reliable. Cold makes materials and systems more fragile. Distance makes repair harder. Surface risk makes maintenance slower. Psychological strain makes decision-making heavier. And all of it feeds back into the stability of the one thing the crew cannot afford to lose, their shelter. The habitat on Europa may therefore become the true center of the mission, more important in some ways than the lander, more emotionally central than the scientific equipment, more sacred than any symbolic human footprint. Because in practical terms, every scientific ambition on Europa would be downstream of habitat survival. If the habitat is stable, the mission continues. If the habitat becomes uncertain, everything else stops mattering. And the cruelest part is this: the more ambitious the mission becomes, the more the habitat has to support. More crew activity, more power usage, more sample management, more drilling operations, more external systems cycling in and out, more dependency, more accumulated wear. Success itself can make the habitat's burden heavier. That means Europa does not merely punish failure, it may punish sustained success. The longer the crew remains, the more the habitat must keep winning against the environment without pause. Day after day, system after system, no gaps, no mercy, no real second chance. And once you understand that, you begin to see the first human mission to Europa for what it really is. Not a story about planting a flag, but a story about building a tiny island of warmth on the edge of physical impossibility and praying that the island remains intact long enough to matter. Before we move on, if this kind of deep, cinematic exploration is exactly why you come to YouTube, subscribe to Skyline Trek and stay with us. This channel is built for viewers who want the full scale of the frontier, not just simplified space headlines. Because next, we descend into the reason Europa matters at all, the hidden ocean beneath the ice. And the more you understand that ocean, the more terrifying the mission becomes. 8. The ocean beneath the ice. Europa's greatest secret. Everything about Europa bends toward one mystery. Not the surface, not the cracks, not even Jupiter looming above it. The real gravity of Europa, the reason scientists keep returning to it in their minds, in mission proposals, in decades of planning and anticipation, is what may be hidden below, a global ocean. Dark, buried, ancient, pressurized, sealed beneath a crust of ice that may be miles thick, an ocean that has never seen sunlight, an ocean that may have existed longer than human civilization has been possible, an ocean that could, in the most profound sense, change everything we think we know about life in the universe. This is the secret that makes Europa more than a moon, because if the ocean is there, and all available evidence increasingly suggests that some form of subsurface liquid water exists, then Europa is not simply frozen, it is layered. It is concealing a second world beneath the first one, a world cut off from direct observation, a world that the surface only hints at through fractures, chemistry, magnetic behavior, and subtle evidence gathered from afar. We have not seen this ocean directly, we have not sailed through it, we have not sampled it with human hands, but its possibility is now so powerful, so scientifically charged, that Europa has become one of the most important astrobiological targets in the solar system. And that is where the emotional structure of this mission becomes almost unbearable. Because the thing that makes Europa worth everything is also the thing that makes it nearly impossible. The ocean is not open to us. It is hidden behind ice, and not just a thin layer of ice you can imagine cracking with simple machinery. We are talking about a shell that may be immensely thick, mechanically complex, and variable from place to place. That means the ocean is not only distant from Earth, it is distant from the surface of Europa itself. A second level of separation, a second frontier beneath the first frontier. That matters because most of the human imagination still prefers exploration stories, where the destination is visible once you arrive. But Europa does not work like that. On Mars, if there is something to see, it is on the surface with you. On the Moon, the mission unfolds in the open. Even on Titan, strange as it is, the surface is the thing you are interacting with. But on Europa, the most important environment may be inaccessible, even after the landing succeeds. The greatest scientific prize lies below the place you can stand. That transforms the mission from exploration into penetration. To understand Europa, humans would not simply need to arrive. They would need to break through the moon's protective shell. And that is not just a technical challenge. It is a challenge of time, power, contamination control, system endurance, and operational patience on a level far beyond what most people casually imagine when they think of exploring another world. Because let's say the first human mission reaches the surface successfully. The crew is alive, the habitat is functioning, radiation is being managed, the lander remains healthy. Now what? If the real purpose of the mission is to understand whether the ocean below is habitable or alive, surface exploration alone will never be enough. Ice samples matter, surface chemistry matters, geophysical mapping matters, but eventually the mission runs into a wall, both literally and scientifically. The wall is ice, and below that wall may lie the answer to one of the greatest questions in history. That means everything begins pointing downward, down through the frozen shell, down through unknown layers, down into darkness. And that is where Europa becomes more than dangerous. It becomes almost mythic, because beneath the white brightness of the surface is something ancient and hidden, a place no human eye has ever seen, a place where the rules of survival may be different, where chemistry may be active, where pressure may be immense, where alien biology, if it exists, may have evolved in total isolation from everything we call familiar. The ocean is Europa's greatest secret because it does not simply sit there as water, it sits there as possibility. Possibility of metabolism, possibility of ecosystems, possibility of chemical cycles, possibility of a second genesis. And because that possibility is so large, humanity may one day feel compelled not merely to orbit Europa or land on it, but to pierce it. That is the point at which the mission changes character again. Until then, Europa is a hostile moon with extraordinary science value. But once you try to reach the ocean, the moon becomes a fortress. Every meter downward becomes effort. Power must be delivered. Heat must be generated. Equipment must function in conditions of crushing isolation. Communication through thick ice becomes a problem. Navigation becomes a problem. Sterility becomes a problem. Retrieval becomes a problem. What sounds clean in the abstract becomes brutally messy in execution. And yet none of that reduces the pull. Because the ocean beneath Europa may be the nearest alien sea humanity can realistically dream of reaching. Think about that. Not an exoplanet light years away. Not a speculative biosignature in a distant atmosphere. An actual ocean in our own solar system. A place that, while extraordinarily difficult to access, is still physically there, waiting. Hidden beneath ice, but not beyond the reach of eventual human engineering. That is what makes Europa so psychologically powerful. It offers a mystery close enough to haunt us, close enough that we cannot dismiss it as fantasy, close enough that mission concepts feel conceivable, close enough that the dream becomes dangerous. And there is another layer here that makes the ocean even more compelling. On Earth, some of the most resilient ecosystems we know do not depend directly on sunlight. Deep in the oceans, near hydrothermal vents, life thrives in darkness using chemical energy. This fact has transformed planetary science. It means that a habitable environment does not necessarily require warm surface conditions and blue skies. It can exist in hidden places, beneath ice, under pressure, powered by chemistry and internal heat rather than direct solar energy. Europa fits uncomfortably well into that possibility. An internal ocean, tidal heating, potential interaction between water and rock, potential chemical energy sources, long time scales. Put all of that together, and scientists see not certainty, but temptation. Enough temptation to justify mission after mission. Enough temptation to keep asking not whether Europa matters, but how much risk humanity is willing to absorb in order to know. And that is where the ocean becomes more frightening than beautiful. Because once the first humans stand on Europa, they will not simply be standing on a moon. They will be standing above a buried answer. And the existence of that answer will create pressure. Scientific pressure, historical pressure, human pressure. The pressure to go deeper, to learn more, to cross the final layer, and enter the place that gives the entire mission meaning. That is why the ocean beneath the ice is not just Europa's greatest secret. It is the engine of the entire tragedy. Because the first human mission may be survivable on the surface only by remaining careful, limited, and conservative. But the scientific logic of Europa pushes in the opposite direction. It pushes downward. It pushes toward the most difficult, most isolated, and most irreversible operations imaginable. The mission can stay safe, or it can stay faithful to the question. The closer it moves toward answering that question, the more dangerous it becomes. And that tension may define every future human conversation about Europa. Before we descend further, subscribe to Skyline Trek if you want more of these long-form space documentaries that follow one mystery all the way to its human consequences. This is where the frontier stops being a map and starts becoming a moral decision. Because next, we have to ask the most haunting question of all. What happens if humans go under the ice? Because once they do, they may become more isolated than any explorers in history. 9. If humans go under the ice, they may be lost for good. There is a point in every exploration story where distance becomes more than geography. It becomes separation. A moment when the explorers are no longer simply far away, but cut off in a deeper and more absolute sense than anyone watching from safety can emotionally grasp. For sailors, that moment used to be the horizon. For divers, it is the moment light disappears above them. For astronauts, it begins the instant Earth is no longer a nearby world, but a bright object in the dark. On Europa, that moment may not happen during the journey through space. It may happen when humans go under the ice, because as dangerous as the surface of Europa already is, the true abyss of the mission begins below it. The surface, for all its hostility, still leaves the crew in contact with the sky, with orbiting systems, with direct communication architecture, with at least some semblance of a route back upward and outward. But beneath the ice, all of that begins to weaken. The sky disappears. Surface navigation ceases to matter. Communications become harder. Rescue becomes even less realistic. Every meter downward transforms the mission from surface survival into entombed exploration. That is not an exaggeration. It is the central terror of Europa. If the ocean beneath the ice is the real destination, then the human mission only becomes scientifically complete once someone, or something carrying human decision-making and dependence, enters that hidden environment. But doing so would create the most isolated human operation ever attempted. Not simply because it would occur far from Earth, but because it would occur beneath a frozen barrier on a moon already too far away for rescue. That means any descent under the ice creates a second layer of entrapment. First, the crew is trapped by distance from Earth. Then they become trapped by depth beneath Europa. That is what makes this scenario feel so different from ordinary deep space imagination. People often hear Europa mission and picture landing, walking, drilling, studying, maybe collecting samples. But the true scientific temptation of Europa does not end on the surface. It points toward a place beneath the ice where the real ocean is waiting. If humans ever choose to follow that temptation directly, they would be moving into an environment where nearly every form of intuitive security disappears. Communication is the first major fracture. On the surface, even with delays to Earth, a habitat can maintain local communications with landers, relays, rovers, and orbital assets. Beneath thick ice, that simplicity breaks down. Signals do not behave kindly through large frozen barriers, especially in an operational environment already full of technical constraints. That means under-ice missions would require carefully designed communication chains, tethers, relay nodes, acoustic systems, cable spools, or other infrastructure. Every one of those systems introduces dependency. Every one of them becomes something that can fail. And when failure happens under the ice, it does not merely make the mission inconvenient. It can sever the explorers from guidance, coordination, navigation, and the possibility of orderly return. Think about that for a moment. A human crew, or even a subset of a crew, entering a subsurface chamber or descending vehicle beneath Europa's ice, would not just be leaving the surface, they would be leaving the last environment where human exploration still resembles something open and recoverable. Below the ice, there is no horizon, no sunlight, no visible path home, no natural cues that the body recognizes as orientation. There is only darkness, instrumentation, pressure, artificial light, and the knowledge that above you is not water, but a roof of frozen isolation between you and every other human being in the universe. That is a psychological threshold unlike anything in human history. And it matters because human survival is not only engineering, it is cognition, it is composure, it is the ability to function under the emotional weight of one's circumstances. An under-ice Europa mission would demand a level of psychological control beyond almost any exploration environment humanity has ever experienced. Even if the descent vehicle is stable, even if the systems are working, even if the science is extraordinary, the crew would know one thing with perfect clarity: if something goes wrong down here, almost no one can reach them. That is the real horror of going under the ice. Not the darkness itself, not even the alien water. The horror is the collapse of reversibility. Every operation beneath Europa's crust would depend on vertical access. The route down would also be the route back. The infrastructure used to maintain warmth, communication, power, and positional certainty would not be optional support. It would be the mission's spinal cord. If that spine bends too far or breaks, the under-ice explorers are not merely in trouble. They may become unrecoverable by definition. A broken tether, a failed relay, a navigation drift, a compromised ascent route, a vehicle power instability, a structural issue in the melted shaft or penetrated corridor. Any one of these could transform an under-ice mission from bold exploration into sealed entrapment. And what makes that even more chilling is that the environment itself would remain profoundly unknown. We speak of Europa's ocean with excitement, and rightly so. But that ocean, if entered, would not greet the first humans with familiarity. We do not know its full chemistry. We do not know its currents. We do not know its layering, turbulence, particulate content, pressure gradients, or potential biological interactions. We do not know whether the underside of the ice is smooth or chaotic. We do not know whether movement through the water would be simple or operationally treacherous. We do not know whether local conditions would remain stable over time. In other words, the first humans to go under Europa's ice would not only be descending into isolation, they would be descending into uncertainty. And uncertainty underwater becomes far more dangerous than uncertainty on land. On a surface, a person can often stop, wait, return, or visually reorient. In a buried ocean beneath ice, there is no casual retreat. Every action depends on equipment, mapping, and trust in systems that are themselves operating in one of the most remote and unforgiving settings imaginable. That means an under-ice mission would not feel like ordinary exploration. It would feel like extending human life into a place where human life has no natural right to exist, which may be exactly why the first crew never comes back. Because if the mission's historical pressure becomes strong enough, if the scientific value of direct ocean access becomes irresistible, then planners may convince themselves that under-ice operations are manageable with enough redundancy, enough autonomy, enough discipline, and they may even be right in limited cases. But the deeper truth is that under the ice, any mission loses the one thing that human exploration has always secretly relied on: the chance to recover from imperfection. Europa may not allow that chance. That is why going under the ice feels so final. It is not simply a descent into water. It is a descent into a place where a crew can become unreachable while still alive. And that may be the most terrifying scenario of all. Before we continue, subscribe to Skyline Trek if you want more documentaries that take these space missions seriously as human realities, not just visual fantasies. Because what makes these frontiers fascinating is exactly what makes them dangerous. And now we need to confront a different kind of threat. Not the risk of being destroyed by Europa, but the risk of bringing Earth to Europa in a way that ruins everything we came to discover. 10. The contamination problem. No one can ignore. There is a quiet irony at the heart of every mission to Europa. The more determined humanity becomes to search for life there, the more dangerous humanity itself becomes to the integrity of that search. This is one of the deepest and most uncomfortable truths in planetary exploration. The explorer is not neutral. We do not arrive empty. We bring biology, chemistry, heat, materials, microbes, residue, exhaust, contamination pathways, and the entire invisible history of Earth clinging to us in layers we barely think about in daily life. On most worlds, this is a technical concern. On Europa, it may become a scientific catastrophe. Because if Europa truly hosts an ocean capable of supporting life, then it is not just another destination. It is potentially a separate biosphere. And separate biospheres are sacred in a scientific sense. They are fragile, not because they are weak, but because once contaminated, the line between what belongs to that world and what came from ours may become permanently blurred. That is the nightmare. Not simply that we fail to find life, but that we find something and can never be sure whether we brought it with us. This is why contamination is not a side issue for Europa. It is central to the mission's moral and scientific design. Every future lander, every probe, every drill, every cryobot, every submersible, and especially every human mission would face the same question: how do you touch an alien ocean without changing it? That question becomes much more serious the moment human beings enter the picture. Robotic missions can be sterilized to a degree that humans cannot. Machines can be built in controlled environments, cleaned aggressively, assembled with contamination in mind, and sent forward with no metabolism, no skin shedding, no breathing, no digestive tract, no bacteria-rich interior. Humans are different. Human presence is contamination pressure by default. We leak biology, constantly. Even inside suits, even inside habitats, even inside carefully managed systems, the human body is a living ecosystem carrying trillions of microorganisms and a vast amount of biochemical complexity. That means a human mission to Europa would not simply be exploring a potentially habitable world, it would be threatening it. And that is a problem on multiple levels. The first is scientific validity. If samples from Europa's surface, subsurface, or ocean begin showing organic compounds or microbial-like signatures, researchers must be able to trust the provenance of those findings. They must know whether the signal truly came from Europa or whether it originated from Earth-based contamination introduced during drilling, sampling, transport, or human presence. Without that certainty, one of the greatest discoveries in history could become one of the most disputed. Imagine the chaos of that moment. A sample comes back with signs of biology. Headlines explode. Humanity believes for a moment that it has found life beyond Earth. But then the doubt begins. Was the sample pristine? Did the drill remain sterile? Did the habitat leak? Did human-associated microbes enter the system? Was the detected chemistry native? Or was it a disguised artifact of contamination? The discovery that should have united science instead becomes a battlefield of uncertainty, all because humanity could not approach the environment without altering it. That alone would be tragic. But there is a second problem, and it may be even more serious. Forward contamination. If Europa has indigenous life, even microbial life, then introducing Earth organisms into that environment could disrupt it in ways we cannot predict. Perhaps our microbes die immediately. Perhaps the environment is too alien, too cold, too chemically hostile. But perhaps not all of them do. Perhaps some survive temporarily. Perhaps they alter local chemistry. Perhaps they create false biosignatures. Perhaps they interact with native systems. Even if they do not take over in some science fiction sense, they may still stain the environment enough to make clean science impossible for generations. And once contamination enters an under-ice ocean, it may be effectively irreversible. That is what makes Europa so morally difficult. Because unlike a barren rock, a living or potentially living ocean world does not simply tolerate intrusion. It demands restraint. It demands humility. It demands that the explorers ask not only can we go, but what right do we have to touch this place with our full biological footprint? Humanity is not used to asking that question honestly. Historically, exploration has often been celebrated for crossing boundaries, not preserving them. We admire the reaching outward, the overcoming of obstacles, the refusal to remain behind. But Europa may force a different ethic, an ethic of non-interference, an ethic where the most scientifically valuable act may not be immediate human presence, but disciplined distance, robotic reconnaissance, careful sterility, extreme caution, patience. That is hard for a species like ours, because when we sense a profound answer nearby, we want direct access, we want eyes on it, hands near it, bodies in the place where history is happening. But on Europa, that instinct may be the very thing that destroys the purity of the question. And there is a third contamination concern as well. One people talk about less often because it belongs to the return side of the mission. Backward contamination. What happens if Europa's chemistry or biology, if it exists, is brought back toward human systems? What happens if samples are transported into habitats ascent vehicles, orbital return craft, or eventually even Earth-facing quarantine infrastructure. The probability of some dangerous alien outbreak may be small or speculative, but the seriousness of the issue is not. Any mission architecture that allows material exchange between Europa's ocean and human living spaces would have to treat containment as sacred, because once the boundary between Earth biology and Europan material is compromised in either direction, the mission no longer remains a one-way act of contamination. It becomes a two-way exchange. That is one more way. Europa increases the risk of never coming back, because the safer the science becomes, the more restrictive the return path may need to be. Quarantine protocols, sample isolation, crew decontamination, system segregation, all of these increase mission complexity, and as always on Europa, complexity means vulnerability. The very act of preserving the science may make 14. Why Europa could be even worse than Mars. Mars has become the symbol of human ambition in the solar system. When people imagine future colonies, future outposts, future human expansion beyond Earth, they almost always picture Mars first. The dusty plains, the rust-colored horizon, the thin atmosphere, the domes and habitats. The image is hard, but it is legible. Mars feels like a frontier, a cruel one, yes, but still a frontier that the human mind can emotionally organize. Cold desert, harsh weather, difficult survival, long distance, but still a planet whose surface belongs to the mission itself. Europa is different, and in one crucial way, it may be worse than Mars by such a margin that the two worlds should almost never be discussed in the same emotional category. Because Mars is survivable through extension, Europa is survivable, if at all, through defense. That distinction matters more than it seems. On Mars, the environment is brutal, but many of its dangers are readable and distributed in ways that allow humanity to imagine building a future there. There is sunlight, however weak. There is a day-night cycle that remains psychologically recognizable. There is terrain that, while hostile, is at least terrain in a terrestrial sense. There is a sky, however thin. There is access to local materials that may one day support industry and fuel production. There is distance from Earth, yes, but there is not the same kind of immediate saturation by lethal radiation at the surface that Europa imposes simply by existing inside Jupiter's magnetosphere. Mars is deadly. Europa may be operationally poisonous. That is the difference. A Mars base might one day feel like a remote settlement, a dangerous one, a fragile one, but still a settlement. A Europa base, by contrast, may never feel like a settlement at all. It may feel like a bunker, a shielded emergency structure continuously hiding from the moon around it. Mars at least offers some version of surface presence. Europa may only offer protected interruption, short bursts, tight calculations, minimal exposure, constant retreat back into engineered shelter. In that sense, Mars still allows the human imagination to expand outward. Europa compresses it inward, and the problems do not stop there. Mars gives you open access to the world you came to explore. If there is geology to study, it is there. If there are ancient riverbeds, mineral layers, sedimentary records, or clues to past habitability, they are on the surface or within reachable subsurface ranges. On Europa, the true scientific prize is buried beneath ice. The surface is not the destination, it is the barrier. So even after surviving the trip and the landing, the mission remains estranged from its central goal. The thing you came to understand lies beneath you, inaccessible without another layer of extraordinary difficulty. That is not how Mars works. Mars presents itself. Europa conceals itself, and concealment changes everything. It means more power, more drilling, more uncertainty, more contamination risk, more infrastructure, more operational exposure, and more chances for something essential to fail. It means that even successful arrival solves less than people assume. There is also a deeper issue here, one that affects the entire psychology of off-world habitation. Mars can at least be imagined as a place where humans may one day spread out, build multiple habitats, establish redundancy, and slowly grow beyond a single point of failure. Europa may never permit that in any meaningful early stage. The environmental hostility is so concentrated, the need for shielding so severe, and the mission constraints so intense that the first generations of Europa presence would likely remain tightly confined, highly vulnerable, and dependent on a narrow web of stable infrastructure. That means Europa punishes scale differently. On Mars, scale may eventually improve resilience. On Europa, scale may initially just multiply complexity. And complexity, as we have seen again and again, is one of Europa's preferred weapons. Because every new system added to survive the moon creates more demands, more power, more maintenance, more mass, more failure points, more things that must remain functional in an environment that never stops trying to degrade them. Then there is the issue of rescue and reversibility. Mars is far enough away that rescue is extremely hard, but the dream of Mars is usually paired with the dream of human continuity there. Ship traffic eventually, repeated missions, a growing industrial presence. Europa does not invite that same optimism. its location inside Jupiter's radiation environment, combined with the need for heavily protected operations and possibly under ice access, means that even a sustained human presence could remain brittle for far longer than a comparable Mars program. Mars feels like a harsh future. Europa feels like a dangerous exception, and that is why comparisons between the two can be misleading. Mars is a destination humanity may try to inhabit. Europa may be a destination humanity only dares to touch briefly, carefully, and at extraordinary risk. This has moral implications as well, because when people say, if we can go to Mars, we can go anywhere, they often smuggle in the assumption that all hard worlds are variations of the same challenge. They are not. Mars tests endurance, logistics, and long-term adaptation. Europa tests whether some environments are simply too layered in their hostility to support meaningful human presence without unacceptable risk. Mars asks, can humans live beyond Earth? Europa asks, should humans follow every scientific prize with their bodies? That is a much more uncomfortable question, because if Europa truly is one of the best places to search for life, then the temptation to send humans there will only grow. And yet the comparison with Mars should force us to think more clearly, not less. A destination can be scientifically priceless and still be the wrong place for a human-first strategy. A world can matter profoundly and still resist habitation at every level. Europa may be exactly such a world, and that is why it could be worse than Mars, in the one way that matters most. Mars might let you build a future. Europa might only let you borrow time. It influences whether humans should go at all. It influences how deeply they should operate. It influences how the mission handles samples. It influences whether under-ice exploration should remain robotic. It influences return design, habitat design, and moral legitimacy. In a very real sense, contamination is where Europa forces humanity to confront what kind of explorer it wants to be. The kind that arrives and touches everything because it can? Or the kind that recognizes that some worlds are too important to approach carelessly? That may sound philosophical, but on Europa philosophy becomes engineering, ethics becomes protocol, restraint becomes mission architecture. And if the first human crew eventually goes, they may carry a burden greater than survival. They may carry the burden of representing Earth without ruining the first truly alien habitat we have ever reached. That is a terrifying responsibility, because failure would not just kill a mission, It could permanently compromise one of the greatest scientific opportunities in the history of our species. Before we move on, subscribe to Skyline Trek if you want the rest of this story in the same long-form documentary style, because next we reach one of the darkest truths in the entire Europa scenario. If something goes wrong there, rescue is not a plan. Rescue is a fantasy. Why rescue on Europa is not a real option. There are some words that comfort us simply because we are used to hearing them. Backup, emergency response, extraction, recovery, rescue. These words belong to a world where distance is limited, infrastructure exists, and human systems can reach one another within meaningful time. Even when rescue is difficult, the concept itself remains emotionally available. There is a belief that if things become bad enough, someone comes, someone launches, someone moves, someone crosses the distance and changes the ending. Europa takes that belief apart, because a mission to Europa would not simply operate far from Earth. It would operate in a region of space where rescue stops functioning as a practical idea. Not because humanity would not want to help, not because mission control would stop trying, but because wanting rescue and being able to deliver it are two completely different things. And in the Jovian system, especially on or beneath Europa, that difference may become absolute. This is the moment where the romance of exploration meets its hardest edge. If a crew is in trouble on Earth orbit, the response architecture at least exists in recognizable form. If a crew is in trouble near the Moon, rescue becomes difficult and uncertain, but not conceptually absurd. If a crew is in trouble on Mars, rescue begins stretching beyond realistic immediacy. But on Europa, inside the radiation environment of Jupiter, on a surface buried in danger, and perhaps operating beneath ice, rescue ceases to be a timeline. It becomes a story we tell ourselves, because the alternative is too hard to say out loud. No one is coming in time. That is the truth. A rescue mission to Europa would not be like dispatching a second aircraft or launching a quick response spacecraft. It would require its own planning, launch windows, enormous transit time, system preparation, crew readiness, payload capacity, orbital insertion, and survival architecture. Even under fantastically optimistic assumptions, nothing about that process is fast in human emergency terms. And emergencies on Europa would not wait. A habitat leak does not wait. Power collapse does not wait. Radiation exposure does not wait. Medical crises do not wait. Loss of thermal control does not wait. Under ice entrapment does not wait. By the time a hypothetical rescue mission even existed as more than an idea, the original crew's outcome may already be decided. That is why rescue is not a real option. It is not simply hard. It is temporally mismatched to the types of failure that would matter most. And this has profound consequences for how the first crew would live. Because once you know rescue is not real, every decision changes. Every EVA becomes heavier. Every system check matters more. Every maintenance issue feels more serious. Every disagreement within the crew carries greater weight. There is no underlying assumption that if things truly unravel, an outside civilization can physically intervene. The crew would exist inside a closed destiny, shaped mostly by what they brought with them and what remains functional around them. That psychological burden cannot be overstated. Human beings are remarkably brave, but part of our bravery often relies on hidden assumptions. The assumption that a hospital exists, the assumption that a call can be made, the assumption that if the worst comes, some wider structure of society will respond. Remove those assumptions, and courage becomes something much starker. It becomes acceptance. The first crew on Europa would know, perhaps better than any explorers before them, that they are operating without the final layer of protection human civilization usually offers its people. That is an extraordinary thing to ask of anyone, and it means that Europa would not just test hardware, it would test the meaning of commitment. A crew going there would not merely be volunteering for danger, they would be volunteering for irreversibility. Not absolute irreversibility at first, perhaps, but enough of it that any serious failure begins moving rapidly beyond intervention. Even on the surface, rescue would be almost impossible, but if the crew is operating beneath the ice, or if ascent systems are compromised, or if the habitat becomes unstable while the orbital support structure remains intact, the mission enters a category of crisis that human beings have never actually experienced. A crisis where technically there may still be ships, systems, and people elsewhere in the architecture, but functionally, none of them can restore what has been lost in the time frame that matters. That is what makes Europa so different from destinations people compare it to. Mars is far, but rescue concepts at least retain some psychological coherence, because Mars exploration is often imagined within a growing human infrastructure. The Moon is harsh, but close. Orbit is dangerous, but connected. Europa is something else entirely. A moon inside a radiation field, orbiting a giant planet, far from the industrial reach of Earth, potentially forcing crews into shielded habitats, and maybe even under ice operations, where the smallest loss of capability can become terminal. How do you rescue someone from that? The honest answer is that most of the time, you do not. You plan so thoroughly, design so redundantly, train so intensely, and build so cautiously that the mission avoids needing rescue in the first place. That becomes the true philosophy of Europa exploration. Not emergency response, but emergency prevention, so strict that the mission almost resembles controlled exposure rather than open adventure. And even then, prevention has limits. Systems fail, humans make mistakes, unknowns emerge, environments surprise us. That is not pessimism, that is exploration history. The first human mission to Europa would therefore carry a harsh and ancient truth into the future of spaceflight. On the farthest frontiers, survival depends less on being rescued than on never requiring rescue at all. And that is a dangerous standard, because no mission can guarantee perfection. No architecture can eliminate uncertainty. The more complex the mission, the more points of failure exist. The more daring the science, the more the mission stretches itself. The more it stretches itself, the more rescue becomes the thing everyone hopes never to say aloud, because everyone already knows it is not coming. That is why the phrase "never come back" begins to feel less like a dramatic title and more like an operational possibility. Not because Europa actively hunts its explorers, but because it offers no practical mercy once their systems fail. And if that sounds harsh, it should, because this is the frontier at its most honest. No mythology, no cinematic optimism, no easy fallback, just a crew, a hostile moon, and the narrow machinery between life and loss. Before we continue, subscribe to Skyline Trek if you want this kind of documentary storytelling more often. This channel is built for people who want the real scale of future space missions, the science, the risk, the meaning, and the hard truths most headlines skip. And now we come to another dimension of the mission that may be just as dangerous as radiation or cold: the human mind. Because surviving Europa would not only require the body to endure, it would require the crew to endure being psychologically farther from Earth than anyone has ever been. 12. Isolation, delay, and the psychological cost. There are places where the human body can survive, but the human mind begins to pay a price. Submarines teach us that. Polar stations teach us that. Long-duration orbital missions teach us that. Isolation studies, confinement experiments, and every history of extreme exploration all teach the same lesson. Human beings do not simply inhabit environments, they absorb them. And Europa would be one of the heaviest environments the human mind has ever tried to absorb. Not because it is loud, not because it is chaotic, but because it is so utterly indifferent. The first crew on Europa would live under a form of separation no human civilization has ever normalized. They would not only be far from Earth, they would know that Earth is functionally out of reach in any emotional time frame the nervous system finds comforting. They would know that communication is delayed, that rescue is fantasy, that every structure around them exists by design and not by natural support, and that beyond the walls of their habitat lies a world where they cannot breathe, cannot linger, and cannot survive without a continuous chain of successful engineering. That knowledge would not disappear after the first week, it would accumulate, and that is the key to understanding the psychological cost of Europa. The mission would not break the mind through one dramatic shock. It would wear on the mind through constant awareness, constant interior pressure, constant contact with the fact that all safety here is artificial, all warmth is temporary, and all normal life has been replaced by a narrow cycle of procedure, maintenance, caution, and restraint. Think about what the crew would lose. They would lose open air, they would lose spontaneity, They would lose immediate conversation with the people they love. They would lose the sense that help can arrive. They would lose ordinary privacy in ways that deepen over time. They would lose the unspoken background trust that the world around them is meant to support life. Even the sky, if they see it at all from the surface, would not comfort them in the ordinary human way. It would not be Earth's sky. It would not mean weather, birds, distance, and home. It would mean exposure. It would mean radiation. It would mean Jupiter hanging above them like a planetary reminder of how far away they are from everything familiar. And if some of the mission takes place under ice, even that sky disappears. This matters because the human mind relies on more stabilizers than we usually admit. Light cycles, open spaces, familiar sounds, social variety, immediate communication, the ability to step outside without calculating survival. On Europa, nearly all of those stabilizers are either absent or artificially simulated. That means the crew would be living inside a psychological chamber built out of necessity rather than comfort. Now combine that with mission seriousness. This is not a tourist journey. This is not even a scientific expedition in the loose sense. This would be one of the most consequential missions in human history. Every crew member would know it. Every error would feel expensive. Every decision would carry not only operational pressure, but historical weight. They would know that the world is watching. They would know that what they do may shape humanity's understanding of life in the universe. They would know that failure is not private. That kind of meaning can inspire people. It can also crush them, because meaning increases pressure. It raises the emotional stakes of every day. It makes exhaustion harder to admit, fear harder to confess, uncertainty harder to expose. A crew under that kind of mission burden may become vulnerable not only to loneliness or homesickness, but to a subtler danger, the feeling that they cannot afford to be psychologically fragile. And that is when real strain becomes dangerous. Small frustrations in confined environments do not stay small forever. Habits become irritating. Silence acquires weight. Delays in communication with Earth make support feel less immediate, less intimate, less emotionally real. Jokes stop landing the same way. Decision disagreements sharpen. One crew member may crave quiet, while another needs reassurance. One may become more rigid under pressure, another more emotionally exposed. These are not signs of weakness. They are signs of being human. But Europa would magnify them because there is nowhere else for the tension to go. The habitat becomes the whole social universe. And unlike on Earth, people cannot simply leave the room and walk into a safe natural world to reset their minds. On Europa, stepping outside is not relief, it is danger. That means psychological decompression itself becomes an engineering problem. Privacy becomes a designed feature. Emotional stability becomes a mission resource. Group cohesion becomes life support. That is a startling idea, but it is true. On Europa, mental resilience would not be secondary to survival. It would be one of the conditions of survival. Because if the crew begins to fracture psychologically, the consequences spread fast. Communication quality drops. Trust erodes. Maintenance discipline suffers. Decision-making becomes more emotionally distorted. Sleep degrades. Stress chemistry rises. Risk tolerance changes. A mistake that might have been caught in a stable crew may slip through in a strained one. In that sense, psychological breakdown does not remain mental, it becomes operational. And that is what makes the psychological cost of Europa so serious. It is not simply sadness in space. It is not just loneliness. It is the slow interaction between isolation, mission pressure, confinement, delayed communication, existential risk, and the knowledge that the environment outside is lethal. The crew would wake each day inside a reality where even success feels fragile. That is hard for the human mind to metabolize over long periods. There is also something deeper at work on a mission like this: identity drift. People on long-duration missions often begin to feel subtly separated, not only from home, but from the normal version of themselves. The rhythms that define personality on Earth begin to loosen. You become, increasingly, the person the mission requires. That can be noble. It can also be disorienting. Over enough time, especially in a setting as extreme as Europa, the crew may begin to experience an unsettling split between their remembered lives on Earth and the stripped-down operational selves they have become in order to endure. And beneath all of this lies the darkest thought of all. What if the crew begins to suspect they are not coming back? Not with certainty at first, just a possibility. A slow realization triggered by failing systems, delayed repairs, rising risk, or mission logic shifting around them. If that realization enters the habitat, even in partial form, the psychological atmosphere changes permanently. Every conversation gets heavier, every memory of Earth sharpens, every mundane task becomes surreal. Hope and denial begin coexisting in the same room. That is not science fiction. That is what irreversible missions feel like when they stop being abstractions. Europa may be the kind of place where that feeling arrives before the ending does. 13. The return mission problem. By the time people imagine a human mission to Europa, they usually picture the arrival in vivid detail. The descent, the landing, the first human steps on the ice, the experiments, the drilling, the search for signs of life. But the most dangerous part of the entire mission may not be getting there. It may be leaving, because a return from Europa is not just the final chapter of the mission. It is a second mission, hidden inside the first one. A mission that only begins after the crew has already survived deep space transit, radiation exposure, habitat fragility, surface operations, possible under-ice work, and the slow accumulation of wear on every system they depend on. And by the time they are ready to go home, if they are ready to go home, they would not be leaving from a healthy, familiar launch complex, protected by an entire industrial civilization. They would be leaving from a frozen moon under Jupiter's shadow, inside one of the harshest operational environments humanity has ever attempted to endure. That changes what return really means. Because on Earth, launches are the product of huge infrastructure, engineers, fueling systems, redundant diagnostics, endless inspection, replacement parts, human support teams, abort options, contingency planning, layered on contingency planning. Even then, launch remains dangerous. Now remove all of that and replace it with a small, isolated, radiation-stressed expedition, relying on a limited set of systems that have been exposed to Europa's environment for however long the surface mission has lasted. That is the real return problem. The ascent system would not be pristine, the crew would not be fresh, the environment would not be cooperative, the margins would not be generous, and yet everything would need to work. That is what makes the return from Europa so haunting. It is not enough for the mission to survive the destination. The mission must preserve a separate sequence of capabilities all the way to the very end. The ascent vehicle must remain functional, propellant must remain viable and properly managed. Guidance systems must be healthy, structural components must have endured the cold and radiation. Docking or rendezvous architecture, if the mission depends on orbital transfer, must still be available and precisely timed. Navigation must remain accurate. Power must remain stable. The crew must still be physically capable of executing a high-stakes departure after perhaps months of operating in one of the most stressful environments imaginable. That is a brutal list of requirements. And what makes it worse is that Europa does not merely demand one successful launch. It demands continuity. Every previous stage of the mission must avoid damaging the return stage. If radiation quietly degrades the wrong electronics, the ascent architecture may weaken. If surface logistics force repeated exposure or increased operational strain, maintenance burdens grow. If habitat problems consume too much time and energy, the crew may reach the departure window already exhausted and under pressure. If local infrastructure shifts toward emergency mode, ascent preparations may become rushed, compromised, or incomplete. In other words, the return does not fail in isolation. It can be weakened by everything that happened before it. That is why Europa is not simply dangerous in a moment-to-moment sense. It is dangerous in an accumulative sense. Every day on the moon would be stealing a little from the perfection the return phase needs. Every EVA, every hardware cycle, every thermal swing, every radiation hour, every strain on power systems, every emergency workaround, every unexpected repair, all of it would be quietly asking the same question: will there still be enough left to go home? That is a hard question to live with, because the crew would know that the return vehicle is not just transportation, it is permission to believe the mission remains reversible. As long as the ascent capability remains healthy, Europa still feels like a place they can leave. The moment confidence in that capability begins to crack, the emotional architecture of the mission changes completely. Europa stops feeling like an outpost and starts feeling like a sentence. And the return challenge may be even more severe if the mission architecture depends on multiple stages. Surface departure may only be the first step. There may be rendezvous with an orbital asset, transfer to a longer-range return vehicle, re-entry planning far in the future, deep space survival during the long trip back, medical stability, quarantine protocols if samples or biological concerns exist. In that sense, going home is not one event. It is a chain, and chains break at their weakest link. That is the larger truth the public rarely sits with long enough. A Europa mission cannot be judged by whether people land successfully. It can only be judged by whether the mission remains fully survivable from launch to return, through every environment it enters. And the farther humanity pushes into the science, the more complicated that chain becomes. If under-ice systems are involved, if sample containment is complex, if local operations consume more time than expected, if surface exposure stresses the architecture, the probability of an elegant return begins to shrink. This is where the title of the documentary becomes operationally real. The first humans on Europa may never come back, not because Europa prevents one specific action, but because returning from that moon demands a level of system integrity that may be almost impossible to preserve after everything else the mission asks them to endure. The problem is not only launch. The problem is launch after Europa has already had time to work on you, and Europa would work on everything. On your hardware, on your body, on your confidence, on your hardware, on your body. By the time the crew turns toward home, they may be doing so with systems that are functional but tired, stable but stressed, operational but less robust than when they arrived. The moon does not need to destroy their departure vehicle outright. It only needs to erode certainty enough that the last stage of the mission becomes the most dangerous one. That is what makes the return problem so terrifying. It is the final demand for perfection from a mission built entirely out of imperfection management. And if that perfection fails, even slightly, there may be no second launch, no backup ascent platform, no rescue stack rising from another pad somewhere nearby. There would only be the realization that the mission's architecture, for all its brilliance, was not enough to carry human beings cleanly through the most unforgiving destination they had ever tried to leave. That is how a frontier becomes permanent. Not when people arrive, when they discover that departure was always the most fragile part of the dream. 15. The life discovery paradox. There is a paradox at the center of Europa that makes the entire mission feel almost cruel in its design. The better Europa looks as a home for alien life, the worse it becomes as a destination for human life. That is the paradox, and once you see it clearly, you cannot unsee it. Because what draws us to Europa is not comfort, not practicality, not expansion, not colonization in the ordinary sense. What draws us there is the possibility that beneath the ice, hidden in the dark, something alive may already exist. That possibility is so powerful that it bends entire decades of scientific attention toward one moon. It turns mission planning into a kind of longing. It makes engineers, astrobiologists, geophysicists, and dreamers all stare at the same frozen world and imagine the same forbidden thing, an ocean that is not empty. But every increase in that possibility also increases the stakes of how we approach the moon. If Europa is probably sterile, then the mission is hard but conceptually simpler. We go, we study, we learn about ocean worlds, geology, chemistry, and maybe the conditions that failed to produce life. But if Europa might actually host biology, then the mission becomes ethically charged, contamination sensitive, and far more dangerous to execute cleanly. The destination grows more important. At exactly the same moment, it becomes less tolerant of human intrusion. That is what makes this a paradox, rather than just a technical problem. The strongest reason to go is also the strongest reason to hesitate. If there is life beneath Europa's ice, then the first human mission would not merely be an expedition. It would be first contact with a second biology, even if that biology exists only at the microbial level. And first contact, in that sense, would not happen through a dramatic encounter between minds or civilizations. It would happen through chemistry, through microscopy, through signatures in water, through subtle evidence that the universe found another way to animate matter. That would be one of the greatest moments in the history of our species. And yet to reach that moment directly with human bodies may be exactly what risks compromising it. This is what makes Europa so emotionally difficult. On one hand, there is almost nothing more meaningful than the discovery of life elsewhere. On the other hand, the very act of sending people to pursue that discovery may endanger the scientific purity of the environment and force the mission into deeper risk than human presence can responsibly justify. The closer humanity gets to the answer, the more careful it must become not to destroy the question. That is a devastating tension, because human beings are not naturally patient in the face of transformative knowledge. We move toward significance. We push closer. We want presence, participation, ownership of the moment. We do not want to merely infer life from orbit forever. We want to know. We want direct evidence. We want the image, the sample, the proof. And if robotic missions keep suggesting that Europa's ocean is chemically rich, dynamically active, and perhaps even biologically promising, the pressure to send humans will grow stronger. History will begin whispering dangerous things, that the mission is too important to delay, that the answer is too close to leave to robots alone, that human adaptability can handle what machines cannot, that no generation should turn away from a chance this large. And all of those whispers may contain some truth. But Europa punishes the inability to distinguish between importance and readiness. That is the paradox again. The life question makes Europa feel urgent. The conditions of Europa make urgency dangerous. This matters not only scientifically, but emotionally. Because the first crew to go there, if humanity ever chooses that path, may know that their mission is not fundamentally about them. It is about what might already be living beneath them. They would not be the main event. They would be the intruders, the seekers, the temporary visitors above a world whose greatest value lies in what it may already contain. That creates a strange inversion in the psychology of exploration. The explorers would not be arriving to claim a world. They would be arriving to ask permission from reality itself, to understand something that does not belong to them. That humility is beautiful. It is also terrifying. Because if life is there, then Europa stops being just an engineering challenge and becomes a place with scientific sanctity. And if the mission fails, or contaminates the ocean, or turns the first contact into a permanent ambiguity, the damage would not be measured only in lost lives. It would be measured in lost clarity, lost trust in the data, lost confidence that we encountered another living system without staining it with our own. That would be a tragedy almost beyond language. Not because humanity dared too much, but because it could not control the consequences of its own presence. And yet the opposite choice is not emotionally simple either. To decide that robots should go first, and perhaps always, may be the wiser path scientifically. But it also means accepting that some of the most important discoveries in history may happen without human beings standing physically at the threshold. That is hard for civilization to accept. We like our great moments embodied. We like the image of someone there, someone seeing what no one has seen, someone carrying the weight of the species in person. Europa may deny us that satisfaction, or rather, it may force us to ask whether the desire for human presence is worth the risks human presence creates. That is the life discovery paradox in its purest form. Europa becomes most meaningful when it becomes least appropriate for careless touch. The stronger the case for life, the stronger the case for restraint. And if humanity fails to understand that, the first mission may become not a triumph of discovery, but a cautionary tale about what happens when a species mistakes proximity for wisdom. 16. Some worlds are not built for human survival. Human beings have a habit of turning frontiers into promises. A new land appears on the map, and somewhere in the imagination, a sentence forms almost automatically. One day we will live there. It happened with mountains, deserts, polar regions, oceans, orbit, and now with planets and moons. We treat reachability as destiny. If a place can be touched, then perhaps one day it can be inhabited. If it can be inhabited, then perhaps one day it can become part of the expanding human story. Europa forces us to question that instinct. Because Europa may be one of those rare worlds that matter immensely, without ever becoming livable in any meaningful human sense. A world that invites study, but resists settlement. A world whose greatest importance may lie not in becoming our next home, but in teaching us the limits of where home can exist. That is not failure, it is maturity. And it may be one of the most difficult lessons space exploration has to learn. Not every destination is a candidate for human flourishing. Some worlds may allow robots, remote science, orbiters, penetrators, automated laboratories, and carefully designed brief contact. But human survival is a different standard entirely. Human survival does not mean touching down for a symbolic moment. It means building enough continuity, enough resilience, enough margin, enough psychological and physical support that life can persist without every hour feeling borrowed from catastrophe. Europa may never offer that. Even if humanity becomes extraordinarily advanced, even if shielding improves, propulsion improves, automation improves, and the moon becomes better mapped than it is today, Europa still combines too many forms of hostility in one place. Radiation, extreme cold, hidden terrain complexity, buried science targets, contamination sensitivity, impossible rescue timelines, fragile habitat dependence, possible under-ice entrapment, severe return constraints. These are not isolated difficulties waiting to be solved one by one until the moon becomes manageable. They are interacting conditions that define the moon's character, and some characters do not soften. That is the world Europa may be. A place where we can arrive, perhaps. A place where we can learn, perhaps. But not a place that welcomes the long continuity human life requires. This matters because space exploration is not only about engineering, it is also about the stories civilization tells itself about its future. There is enormous power in the dream that humanity can go anywhere and live anywhere with enough determination. That dream fuels ambition, investment, innovation, and courage. But if that dream becomes absolute, it blinds us. It makes us interpret all worlds as versions of the same puzzle when they are not. Some places may not be waiting to become human environments at all. Some places may remain what they are, deeply valuable, deeply mysterious, and fundamentally outside the category of worlds meant for us. Europa may be one of the first places to make that truth impossible to ignore. And if so, that would make it historic in a different way. Not because it became the next step in human settlement, but because it taught us that the universe is not a blank canvas for our expansion. It is a landscape of radically different realities, some of which permit us only the briefest, most careful kind of contact. This has philosophical weight, because for centuries, humanity has often measured progress by how thoroughly it can occupy what it discovers. To map becomes to approach becomes to enter becomes to stay. Europa interrupts that logic. It suggests that staying and understanding may diverge, that the most scientifically important choice may be not to live there, but to preserve the conditions under which it can be studied honestly. That takes a different kind of courage. The courage not only to go, but to refrain, not only to reach, but to stop, not only to prove we can survive somewhere, but to ask whether survival there serves the thing we most need to learn. If that sounds like a retreat, it is not. It is a refinement of what exploration means. Exploration does not always culminate in settlement. Sometimes it culminates in perspective. Sometimes the frontier changes us, not by becoming ours, but by revealing that we are not entitled to every form of closeness. Europa may do exactly that. It may become the world that teaches humanity the difference between access and belonging. And that lesson could matter far beyond Jupiter. Because as our telescopes improve, and we discover more extreme exoplanets, more ocean worlds, more strange moons and hidden habitats elsewhere, we will need a more mature language for the future. Not just can we get there, and can we survive briefly, but what kind of relationship does this place allow? Europa's answer may be stark. You may visit, you may study, you may learn, but do not mistake that for permission to remain. If that is true, then the first mission there may be remembered not only for what it found, but for what it taught civilization about restraint, humility, and the boundaries of human survivability. Some worlds are not built for us, and one of the hardest things an ambitious species can do is accept that truth without turning away from wonder. 17. Why this is becoming a real question. Now, for a long time, Europa belonged mostly to the realm of speculation. A fascinating moon, a compelling scientific target, a distant ocean world candidate that fired the imagination, but still felt safely beyond the range of immediate human planning. That is changing. Not because humanity is launching astronauts to Europa tomorrow. It is not. But because the chain that leads to such a question is already underway. Every serious robotic mission, every new dataset, every refined model of the ice shell, the ocean, the radiation environment, and the moon's chemistry moves Europa from myth toward engineering. The more real the moon becomes scientifically, the more real the future choices around it become strategically. That is how difficult destinations enter history. They do not begin as crude missions. They begin as knowledge. First we map, then we characterize, then we test systems, then we narrow uncertainties, then we start asking whether robotic access is enough. This is the stage that matters most, because it is where civilization decides whether knowledge will produce caution or momentum. Europa is becoming a real question now, because humanity is no longer just daydreaming about icy moons in the abstract. We are entering an era where targeted missions, improved instrumentation, and serious long-range planning can transform Europa from a mysterious point of light into an operational environment with known parameters. And once enough parameters are known, the conversation inevitably changes. The impossible becomes the difficult becomes the long-term becomes the next great project somebody thinks history demands. That is why this matters now, even if the first human mission still lies far ahead, because future missions are being shaped by the assumptions we normalize in the present. If we speak about Europa only as a triumph waiting to happen, then we train ourselves to overlook the scale of restraint it may require. If we treat it only as a natural next step after Mars, we flatten the profound differences that make Europa unique. If we talk about the search for life there as a destination that obviously culminates in human presence, we may be setting the emotional terms of a mission long before the ethics and survival realities have been honestly confronted. This is when narratives become dangerous, because space exploration is funded partly by science, but it is sustained emotionally by stories. Stories about destiny, stories about the frontier, stories about what humanity is meant to do next. And once those stories harden into expectation, they begin exerting pressure on real mission architectures. They make caution feel timid. They make delay feel like weakness. They make the world itself seem like an invitation, when it may actually be a warning. Europa does not need dramatic overstatement to be compelling. It is already compelling enough. That is why the real question is becoming unavoidable now. As our capabilities grow, will our wisdom grow at the same pace? Because one day, the technical barriers will shrink, radiation shielding will improve, autonomous systems will improve, long-duration mission support will improve, drilling concepts will improve, deep space habitation will improve. The raw engineering arguments against reaching Europa will become less absolute than they are today, and when that happens, what remains are the harder questions. The questions no amount of hardware solves by itself. Should humans go if robots can do the science more cleanly? Should we prioritize presence over purity? How much risk is justified by the possibility of discovering life? What counts as acceptable contamination risk for a second biosphere? At what point does exploration become intrusion? Those are not future questions in the sense of being irrelevant now. They are present questions in preparation for the future. Because by the time humanity has the means to seriously debate a crewed Europa mission, the emotional direction of that debate may already be set. That is why this documentary matters now. Because we are still early enough to think clearly. Europa is not yet crowded with hardware. Its mythology is not yet irreversible. Its role in human imagination is still being formed. This is the moment to decide whether our relationship with the moon will be shaped by maturity or momentum. And that choice may become one of the defining decisions of deep space civilization. Not because Europa is the only difficult world, but because it concentrates so many themes in one place. The search for life, the ethics of contamination, the danger of distance, the fragility of human systems, the temptation of significance, and the question of whether every answer must be pursued through human physical presence. In that sense, Europa is not only becoming a real question because of the moon itself, it is becoming a real question because humanity is approaching a threshold where our tools may soon be strong enough to reach places our judgment may not yet be ready to inhabit. 18. Final reflection. The frontier that may not let us leave Europa is one of the most beautiful traps the human imagination has ever encountered. From far away, it looks almost serene, a pale moon crossing the darkness beneath a giant planet. Bright, silent, elegant. But the closer we look, the stranger it becomes. The surface cracks, the ice hints at motion. The science points downward into hidden water. The possibility of life begins to breathe inside the mind. And suddenly this distant moon stops being scenery and becomes a question. A question so large that humanity may one day feel unable to resist it. That is what makes Europa so powerful. It is not just dangerous. It is meaningful. And meaning is what pulls us into risks we would otherwise reject. We do not go to places like Europa because they are easy. We go because they might tell us something so profound that the danger begins to feel secondary. In this case, the thing Europa may tell us is almost impossibly important. Whether life exists beyond Earth, whether biology began more than once, whether dark oceans under frozen shells can hold chemistry long enough and energetically enough to become alive. That possibility is enough to move a civilization. But Europa is also the kind of place that forces us to ask what moving a civilization towards something should actually mean. Should it always mean sending people? Should the highest form of exploration always be embodied? Should every great unknown be answered by human presence, even when human presence may compromise the thing being sought? These are not side questions. They are the center of the Europa story. Because everything we have followed tonight leads back to one hard truth. Europa does not merely challenge human exploration. It challenges the assumption that exploration and survivability always belong together. It presents a world where the scientific prize is enormous, the human risk is extreme, and the line between bravery and irreversibility may be thinner than any mission planner wants to admit. The first humans who go there, if they ever do, would not just be explorers. They would be participants in one of the most morally and operationally demanding missions in history. Every step would happen under pressure. Every success would depend on shielding, systems, discipline, and luck holding together longer than the environment should reasonably allow. Every hour would be lived inside the awareness that this is not a place designed to support them. It is a place they are borrowing time from. And perhaps that is the clearest way to understand Europa. Not as a future colony, not even as a future base in the ordinary sense, but as a borrowed place. A moon that may allow brief contact, careful science, and astonishing discovery, but only under terms so severe that return itself becomes uncertain. A frontier, where arrival may be possible, and departure may remain the most fragile part of the dream. That is why the title of this journey is not really about pessimism, it is about honesty. Why might the first humans on Europa never come back? Because Europa combines too many unforgiving realities in one place. Distance that destroys rescue, radiation that attacks bodies and machines, cold that turns survival into constant thermal resistance, surface conditions that remain uncertain, an ocean hidden beneath a shell that makes the real destination even harder to reach, a contamination problem that makes the most important science more delicate the closer humans get, a return sequence that demands perfection after everything else has already consumed the mission's margins. Any one of those challenges would be daunting. Together, they become something else. They become a world where the cost of knowing may be permanent. And yet, even now, Europa remains worth thinking about, worth studying, worth reaching toward with intelligence and humility. Because the universe is not less beautiful when it resists us. In many ways, it becomes more beautiful, more honest, more instructive. It reminds us that wonder does not always come in forms that welcome habitation. Sometimes the greatest mysteries are hidden inside places that ask us to choose carefully how close we should get. That may be Europa's deepest lesson, that not every frontier is meant to be conquered. Some are meant to be approached with reverence. Some are meant to change us more than we change them. Some are meant to remind us that the search for life beyond Earth may also be a search for wisdom within ourselves. And if humanity one day stands on that frozen moon beneath Jupiter's shadow, looking out across a world of ice while knowing an ocean lies below, then the greatest question may not be whether we were capable of getting there. It may be whether we were wise enough to understand what kind of place we had entered, because Europa may be one of the greatest destinations humanity ever chooses. It may also be the first great frontier that does not let its explorers leave,